Year 10. This is the first of two videos of part of your GCSE Forces in Balance topic. Lesson 1, your title would be Characteristics of Forces, and if you're following the combined course you'd find information in the book on page 98-99 if you're following the separate physics 114-115. Essentially trying to put over four things to you today. Firstly, by the end of the lesson you should be able to recall the difference between contact and non-contact forces and be able to give examples of them. And secondly, recall the difference between a scalar and vector quantity and again be able to give examples of them. Okay, as a subtitle you need the title Contact and Non-Contact Forces. Notice in red here on the slide it says for your notes, so you must either make a copy of what's on the slide here or print it off for your own notes. I really don't mind which you do. Okay, so all forces can be classified as either contact or non-contact forces. Forces that have to be in physical contact with a body to exert a force are called contact, quite logically, and those which can act at a distance are called non-contact forces. You need that down in your notes. You'll also need to draw up a table which has got the column headings contact force and non-contact force, and what I'd like you to do is to classify each of these forces as either being contact or non-contact. At this point you should pause the video and do that now, please. Okay, some of those are quite easy, some of them are a little bit more difficult. So let's look at the solutions then. Let's look at the contact forces first. Upthrust is the force that keeps you afloat in water, so that water actually has to be in contact with your body, so that's a contact force. Tension of a string, this tension has to be within the string, so it has to be again in contact with the string. Air resistance, the air has to be in contact with the moving body to create the force of air resistance. Reaction force is the force between two bodies which are touching. One exerts a force on the other and the other exerts a reaction force back on that body. So that again is a contact force. And likewise friction, as you well know from year 7, bodies have to be in physical contact for friction to apply. Non-contact forces, electrostatic or static force. Weight, so when you drop something from a height, the earth doesn't have to be in contact with that object in order to attract it, so it's a non-contact force. And again, maybe in primary school you played around with magnets. Magnets don't have to be in contact with each other to exert a force, so they are non-contact forces. Okay, so that was covered, believe it or not, in year 7. This is brand new, and again this is a section that needs to be written into your notes or the slide printed off. Title is Scalars and Vectors. Now, once again, we can subdivide forces or any quantity into what's called a scalar or a vector quantity. A scalar quantity has got magnitude or size only. That's what we mean by magnitude, size. For example, temperature. It doesn't have an associated direction with it, so you just say 50 degrees Celsius. You don't say something like 50 degrees Celsius due east. Whereas a vector quantity has both a magnitude and a direction. All forces are vector quantities. Do remember that, that's quite important. You do say a force on an object is 20 newtons downwards or to the left, to the right or up, etc. It must have a direction associated with it. So a good way of describing a vector is simply by having an arrow giving a certain direction and of a certain length. The direction obviously gives you the direction which the force is acting, and the size of the arrow gives you an indication of how big that force is. The longer the arrow, the bigger the force. Okay. This idea is quite important when we start to add vectors together later. Pause the video and make sure that you've got that note written down. Okay, let's see if you've understood that then. There's a little situation here whereby Tilly travels by bus from her home to school. The diagram shows her journey. Which of the following statements are true? So if we look down here, there's her home. She goes by road on the bus, following this route here, like so. Okay. And it then says which of those statements is true. It says the displacement of her school from home could be represented by an arrow starting from her school and ending at her home. Displacement is a vector quantity. It's distance in a given direction. So that first statement there is true. The displacement represented by a single line with an arrow. Okay, the distance and displacement are the same thing. Well, the displacement is the distance travelled in a straight line. The distance is simply the distance she's travelled along the road. So there is a difference between the two, so that is false. Distance is a vector quantity. Well, can you see here how the direction is constantly changing here? When we talk about how far something is away, what's the distance between there and there, you'd say it's 5 miles or whatever. You wouldn't say it's 1 mile due north, then 3 miles due west, what have you. Okay, so distance is a scalar quantity, it's only got size. So the first statement there is false and the second statement is therefore true. The size of the displacement of her school from her home is less than the distance. Well, that's true, isn't it? You can see here the distance in a straight line is going to be less than the total journey she travelled, the total distance she's travelled by bus. So that is true. And displacement is a vector quantity. Yes, it's got size, so many miles, and it's got direction, in this case, due east. Okay folks, what I'd like you to do now, under the title task, and again this is for your notes, so it must be done in your book, can you draw up a table with the heading shown scalar quantity, vector quantity, and can you therefore have a go at categorising those words, those quantities down there as being either scalar, size only, or vector, size and direction. It'd be a good idea to pause the video whilst you're doing that. We'll then go through the solutions together. Okay then, solutions, scalar quantities, size only, speed, energy, measured in joules of course, is just an amount, distance, we've talked about a few moments ago, just a size, how many miles, how many meters, volume, scalar quantity, so many millilitres, so many litres, so many meters cubed, area, meters squared, similarly, and mass, kilograms, scalar quantity. The vector quantities on the right hand side, weight, which is the force of gravity acting on a mass, so that's got a direction down towards the centre of the earth. Velocity is the speed in a given direction. That's quite crucial later on in the course. So velocity is a vector quantity, has size and direction. Drag is a force, air resistance. So again, that has size and direction, often opposing the direction in which something's moving. And again, as we discussed earlier, displacement is the distance in a given direction, distance travelled in a straight line. So that is vector quantity. Hopefully you found that okay. Okay then folks, you should now know, or you should now be able to recall what a contact force is, i.e. it requires physical contact to act on a body, whereas a non-contact force can act at a distance. You should know that friction, air resistance and tension are all examples of contact force, and that magnetic, electrostatic and weight, gravity, acting on a mass are examples of non-contact forces. You should remember that a vector quantity has a magnitude, size, and a direction associated with it, whereas a scalar quantity just has magnitude. And you should be able to give some examples of both. So know that weight, velocity, displacement, and air resistance are all examples of vector quantities, and that temperature, mass, distance and speed are all examples of scalar quantities. Please remember that all forces, weight, air resistance, are vector quantities.